Hello everybody, Senior Engineer MBA on Investor, and in today's video I want to take a look at this interview between Brad Lankar and Beam Therapeutics CEO John Evans. And of course this interview was published here on Twitter, and I said, you know what, let's go ahead and play this interview. And within the first 2 minutes I was like, okay, I'm making a video on this because look, guys, I'm an investor of Beam Therapeutics. I'm a huge supporter of Beam, but there are certain claims that, we got to be careful. As much as you support a company, as much as you support an individual, a leadership, you got to be open-minded and sort of understand, why they're saying certain things and not just follow blindly, right? So you'll understand what I'm saying in just a second here as I play this clip. So let's go ahead and play it and let's see how far we get into it. And I'll be pausing to give my thoughts here because I think there's couple things we have to talk about.
Most people are familiar with base editing, but in case not, everyone's heard of CRISPR. What's the difference between that and base editing?
Yeah, so this is part of the field where we're trying to make one-time cures. One therapy and hopefully a lifelong change. And that begins with gene therapy, where we're adding more gene with viruses. But the idea was always editing would be better. You'd like to go into the genome and fix it. And so you have really two challenges. So the first generation of editing tools solved the first challenge, which is targeting. How do you find one address in the genome to target? And you had zinc fingers and talons, and then of course CRISPR, really made that efficient. And so that's great. But the problem is all those tools, once they get to the target site, the only thing they do is cut. So you're making a double-stranded break. And that is a blunt tool that will knock out genes, but it's not as easy to make precise changes. And so Beam really results from the push to make it, even better and make a tool that, in our case, uses CRISPR for targeting, but not for cutting. Instead, we land on the target spot and we use a deaminase to do a single base change. It's literally doing chemistry on the genome without needing to cut the chromosome. And basically, that's a precise, versatile, and highly efficient editing system for a lot of kinds of genome modification.
So, really quick, guys. Look, I wholly agree with the Beam Therapeutics part, where whatever they're trying to do is obviously they're trying to achieve more efficiency, more accuracy, which obviously do matter when it comes to human health, right? Human therapeutics. What I disagree here is that Evans sort of bundled CRISPR, talons, zinc as one bubble. Basically, that's what Evans just did. He just said, you know what, zinc's talents and CRISPR, they all do this targeting and they all do this cutting, right? And it just feels like he's putting all of that in one bubble, and then he's putting his own, base editing as a other whole bubble of technology that should be separate, completely separated from the field of whatever CRISPR was in his definition at the beginning here. What is ironic here is that he actually does mention that they use CRISPR with part of base editing. Base editing is a form of a specific technology under the CRISPR umbrella, right? But look, let's go ahead and play this video. Let's see how far we get into it.
And your first programs are what we call ex vivo, which means you're doing all of that engineering outside of the body. I have to admit, one of my pet peeves of biotech right now is that all of these gene editing companies that are out there have the same two lead programs, beta thalassemia and sickle cell disease. Those happen to be your lead programs too. Why are you going to be the one that succeeds in those areas?
It's a great question. It's important to remember a couple of things. One is, we're a technology company. We're trying to prove new technologies. So a place like sickle cell where you can get the cells, you can do the work, and we can all benchmark against each other is actually kind of valuable to work some of that out. The second thing I would say is we have not cured everyone with sickle cell disease yet. And so I think until we have done that, I think it's too early to say that we're overcrowded. I think this is overdue, actually. In terms of the competitive landscape, we just felt that we had something to bring to the table. Obviously, you have Bluebird, which we think will get to the finish line with lentivirus. You have a bunch of nuclease programs, of which CRISPR Vertex looks like they will get to the finish line first. And then we're the only, play in terms of the next generation of these tools with base editing. And so, we think we owe it to patients, frankly, to bring it forward. And I think that ultimately Beam 101, our lead program, can deliver, more editing of cells, higher levels of fetal hemoglobin, lower levels of the sickle globin, all with a non-cutting, non-viral approach. And then we have next generation versions that will even do all of that, hopefully with an even more tolerable regimen, better conditioning for patients. So we have a long-term view, and we do think that we're going to bring hopefully best-in-class products for patients.
Yeah.
I think that's. I'll be honest with you. I know Brad is a big person in the social media space when it comes to news outlets and so on. But I will say that was actually a dumb question. Sickle cell disease. There's like so many people with sickle cell disease. If you have 10 companies working on it, well, you should have 20, right? Because right now there's no really form of cure that you can sort of scale that to cure potentially all patients. And again, you don't edit out the germline, so you're always going to have patients with sickle cell disease. I mean, I understand his point that he was making from that question. It was more a rhetoric question than anything, but I'll be honest, that's quite of a dumb question.
That's a good way of putting it. It's a high-class problem for the industry and for patients. More things are great for them.
Competition is great for patients.
Yeah, absolutely. So where we, envision this heading one day is in vivo. So actually doing the genetic editing in the body. Some companies are actually already doing that. And I think one of the unsung heroes of science over the last few years is the lipid nanoparticle. Mm-hmm. That's what made the mRNA vaccines possible, for example. They use that as their delivery vehicle. And if in vivo editing is going to succeed, LNPs have to be tremendous. And I'll bet the technology has really improved just over the last few years. I know you're working on it. Can you explain some of that?
Yeah. So I think we believe actually that the future of our portfolio is both ex vivo and in vivo. I think there's real potential to do different things in each setting. But for sure, in vivo is a part of that. And so, and you're absolutely right. We love lipid nanoparticles as the vector of choice today for in vivo. They're synthetic, they're scalable, easier to manufacture. You can redose them. There's a lot to like. And we know a lot about it, actually. And in fact, you mentioned the vaccine. So our president and chief scientific officer is Pino Ciaramella. He was at Moderna for many years and actually started their whole vaccines group. And the ultimate COVID vaccine is actually built on a template that he helped develop for a different coronavirus vaccine. So we are all over that. I think for editing, it's a beautiful fit. You go in one time and we're going to edit, in this case, in the liver. And so that would be things like our glycogen storage disease program, Beam 301, our alpha-1 antitrypsin deficiency for Beam 302. Those are places where we're going to make literally single base changes in the liver of these patients to hopefully fix the mutation that's causing their disease, the one letter that's misspelled, and do that in vivo. So this will be, I think, the first time in the industry that you're literally fixing the mutation in the body. I should also note that we are big believers that LNPs can do even more than the liver. So we actually have a platform where we can use barcoded LNPs dosed at high volumes in animals to then track where do different LNP formulations go, and hopefully identify LNPs that can go to different places other than the liver. We would like to go to blood stem cells for things like sickle cell. Yeah. We'd like to go to immune cells. We'd like to go to the CNS, muscle, lung, heart, many other places. Yeah. And that's research that's ongoing, and we're quite excited about it.
And where are we with clinical development with that? Like Intellia is doing studies already all outside the United States. Your partner Verve, by the way, I'm doing a video with Sek on Wednesday. Can't wait to meet him. That's going to be a lot of fun. They have a study outside the United States. They actually filed an IND, and it's on clinical hold right now. When do you think U.S. regulators might feel a little more comfortable about allowing studies to take place here?
Yeah, I think it's coming. I think U.S. regulators are learning this science as we are, right? And so our job as a company is to bring that to them, figure out what they're looking for in these packages, and then help them answer the questions that they have. So this is all very actively ongoing. Our sickle program was open in the U.S. on the first try. Our CAR-T product, we had a clinical hold, minor requests, we fixed those, we're open now. So the next one is in vivo. And so obviously Intellia has said they're planning to go into the US this year. Verve is on hold, but they feel like they have a path. We've gotten pre-IND advice on our first liver program, Beam 301 for glycogen storage disease. We also see a path forward, and we do anticipate filing that one in the US at this point. So I think this will happen, and I think it'll be a big growth area. In general, we see the FDA as being very constructive on gene editing and just partnering with the companies on the best way to do this.
All right. So let's talk about CAR-T. I actually want to pick up on a conversation that you and I had on Twitter and kind of expand on it a little more. I'm going to be doing a lot of these videos with CAR-T players this week. And, we've been having this autologous versus allogeneic debate for many years. I have to admit, I think one of the big disappointments of the biotech industry over the last few years is that allo hasn't really come to fruition yet. And it's been difficult because the cells don't really expand and persist like we hope. So I mentioned that on Twitter the other day, and you talked about how with new editing technologies that we'll just be able to do so much more to those cells to help them evade the immune system so that they'll have better persistence. Can you talk about that?
Sure. Yeah, so CAR Ts have been a revolution. Cell therapy is going to be a major part of the therapeutic landscape of the future. And cell therapy and gene editing go really well together. It's like peanut butter and chocolate. Like they really want to live together. But also I think the more the better, right? So making a cell invisible to the immune system is pretty sophisticated.
Right.
So I think it's not too surprising to us that it's going to take more than one edit. Beta 2M knockout is probably not enough. And I think we're seeing that in the data now. And so when we think about that challenge, I think for us it's really about higher levels of engineering, right? We just have to be smarter than the immune system. And so in our minds, we've done a lot of work in this area. We think it's more like 4, 5, 6 edits, not 1 or 2, to really make a cell invisible. And from our perspective, that's where we get involved and get excited, because actually that goes back to yet another advantage of base editing, where if you do 4 to 6 edits with a nuclease, you're making a lot of cuts in the genome at the same time. You'll get rearrangements, you'll get cell viability kind of crashes, and it really is a challenge. With base editing, because we don't cut, we can silence genes and knock down proteins as many as we want without any effect on the cell. So it's a big advantage of doing multiplex editing using base editing for this kind of application. And so we are investing a lot, and we think that there's a chance to really create the future of cell therapy, allogeneic, highly engineered, highly efficacious cells using base editing to make a lot of different edits. And I think that will take us to where we want to go in the field in the future.
Yeah, I think of it as like a Swiss Army knife. It's like it has one tool right now, and we'll be able to engineer a lot more tools. Well, John, it's been a very long day. I know you've been stuck in a room, like meeting with investor after investor. I've had a long day. I'm going to get some dinner, maybe a couple of drinks, and I'll be back tomorrow with some more videos. I hope you enjoy them, and really great to see you again. Thanks for joining me.
Thanks so much, Brad. Great to see you all.
So, I think this was an interesting interview. First of all, I do want to shout out Brad for doing this type of interview. That's amazing. Second of all, I think most of the questions were really relevant. In fact, they were really good, actually. The delivery one was good. The only one I thought was done was the sickle cell disease one. I just thought, I don't know, it just rubbed me the wrong way. Just even asking that question, anyways, whatever. I will say one thing about Evans is he is an English major. People don't forget about this, and he knows how to speak. He knows how to speak. He knows how to use certain words, certain sentences, certain tonality. And the reason why I'm bringing this up is he has the skill of actually, instead of talking about base editing and multiplex editing like towards the end, he first takes this opportunity to explain why traditional, CRISPR cuts are not, efficient and sufficient for something like multiplex editing. And that's how he's able to tie that and promote, Beam Therapeutics technology when it comes to multiplex editing, which, I think it's a really interesting way of communication. I think Evans is really good. Like I said, I'm an investor for Beam Therapeutics. I have no reason to put them down at all. I'm a huge supporter of base editing, but I think we have to be careful when we're trying to promote one of the companies that we invested in. We want to be fair. We want to be open-minded, and there are facts involved. Evans didn't mention NTLA when he talked about in vivo. Luckily, Brad did, but Evans did not. He, in my opinion, if he wanted, he should have mentioned in vivo because. NTLA, because when it comes to in vivo, NTLA is the leader in that, right? Regardless of if they're using base editing or not, when it comes to in vivo, NTLA has 2 successful CRISPR programs with human data. Beam Therapeutics doesn't even have human data to begin with. So I think you have to give credit where it's due. I think you have to be impartial when you give these types of answers. I think Beam Therapeutics, whatever they're trying to do, whatever they're trying to achieve here with their leadership and with where they stand in 2023, I think people are feeling really good about this company regardless of having no human data right now. And we're not going to get any sort of human data this year based on our last video. So I think we gotta be careful. We gotta be careful, guys. We gotta be careful. I don't want to mislead investors. You guys know, as much as I want to support the companies that I've invested in, everybody wants to do that, right? You're always gonna want to promote your own companies that you put your hard-earned money in. But I think the key of growth and the key of evolving as a human, as an individual, is to be honest, to be open-minded, and is to be impartial when it comes to data, when it comes to science, right? As much as you want to talk about how good, you believe and how strongly you believe about a technology, about a company, I would highly advise individuals to be open-minded and sort of talk highly of other companies, because ultimately all these companies are trying to do something extremely noble. They're trying to achieve something that has never been done in the past. Regardless if your technology is like 5% more efficient, 10% more efficient, I mean, you got to give where credit is due, and we are all standing on shoulders of giants. So I'll end this video like this, guys. I just wanted to make this quick video on his interview. I think it was a great interview. Great job, Brad. Thank you so much for watching, guys. As always, subscribe if you're not subscribed. Like this video if you have value. And I'll see you guys in the next video on Sunday. Have a beautiful Saturday and a beautiful weekend. And let me know in the comments below, what do you guys think about this interview? Thank you.